Hello friends, welcome to Learn Easy. Today in this session we will discuss resilience, proof resilience, strain energy for gradual and suddenly applied load. Resilience, the ability of material to absorb energy when it is deformed elastically and then release that energy upon unloading. And proof resilience, the maximum amount of strain energy a material can absorb without undergoing permanent deformation. That is proof resilience. Proof resilience is denoted by Umax. Umax is equal to sigma max square into V divided by 2E, where V is volume of the body, E is Young's modulus. Now, strain energy for gradual and suddenly applied load. Gradual loading, sudden loading. Del L P, it is load. X axis represents deformation del L and y axis load P. Del L and P. In case of gradual loading, the curve will be like this. Here, stress is equal to P by A. In case of sudden loading, the graph will be like this. Here, stress is 2P by A. Stress in sudden loading is double of stress in gradual loading. Now, in case of gradual loading, maximum stress sigma is equal to P by A. In case of sudden loading, maximum stress sigma is equal to 2P by A. Maximum deflection we know stress by strain is equal to P by A, stress is P by A, strain del L by L is equal to E. From here we will get del L by L is equal to P by AE. So del L is equal to PL by AE. So this is maximum deflection in case of gradual loading. In case of sudden loading, maximum deflection in similar way, stress by strain is equal to stress is 2P by A divided by here stress is 2P by A. Strain del L by L is equal to E. From here we get del L by L is equal to 2P by AE. And here we get del L is equal to 2PL by AE. For sudden loading. Now strain energy U is equal to half sigma epsilon V. We can write half sigma stress epsilon strain epsilon we can replace sigma by E into V. Is equal to half P by A, sigma is equal to P by A into P by AE into AL. V is equal to AL, area into length. Now if we cancel this A and A, we will get P square L by 2AE. P square L by 2AE. So we can write U gradual is equal to P square L by 2AE. In case of sudden loading, U is equal to half sigma epsilon V is equal to half sigma, we can replace application by sigma divided by E into V is equal to half. Here sigma is equal to, stress is equal to 2P by A. So 2P by A into 2P by AE into A into L. If you cancel this 2 by 2, this A by A, we will get U sudden is equal to 2 P square L divided by AE. Now we can, from these two, we can say that US is equal to, U sudden is equal to 4 U gradual. Strain energy for sudden loading is equal to 4 times of strain energy in gradual loading. Calculate the strain energy stored in a bar 2 meter long, 50 millimeter wide and 40 millimeter thick when it is subjected to a tensile load of 60 kilonewton. Take E is equal to 200 GPa, gigapascal. Here given length of the bar 2 meter, wide of the bar 50 millimeter, thickness of the bar is 40 millimeter. P is equal to 60 kilo Newton is equal to 60 into 10 to the power cube Newton. U is equal to, and E is given 200 GPa, gigapascal, is equal to 200 into 10 cube Newton per millimeter square. Because 1 gigapascal is equal to 10 to the power cube Newton per millimeter square. Volume of the bar V is equal to length into width into thickness is equal to 2 meter means 2000 millimeter. So 2000 into 50 into 40 millimeter cube. Here it will come 4 into 10 to the power 6 millimeter cube. Now stress is equal to P by A is equal to 60 into 10 to the power cube divided by area 50 into 40 Area means cross-section area. Newton per millimeter square. If we cancel, it will be 30 Newton per millimeter square. U is equal to sigma square into V divided by 2E. If we put the value, then 30 square into 4 into 10 to the power 6 2 into E is 200 into 10 to the power cube Newton millimeter. If you cancel, then we will get 9 into 10 to the power cube Newton millimeter. Or we can write it 9 kilonewton millimeter. This is the answer. An axial pull of 20 kilonewton is suddenly applied on a steel rod 2.5 meter long and 1000 millimeter square in cross section. Calculate the strain energy absorbed. E is equal to 200 gigapascal. Given P is equal to 20 kilonewton is equal to 20 into 10 to the power cube Newton. L is equal to 2.5 meter. Cross sectional area 1000 millimeter square. 2.5 meter is equal to 2.5 into 10 to the power cube millimeter. E is equal to 200 gigapascal is equal to 200 into 10 to the power cube Newton per millimeter square. Since 1 gigapascal is equal to 10 to the power cube Newton per millimeter square. U is equal to, we have to find out U. Calculate strain energy. So U is equal to sigma square by 2E into V. Suddenly applied load. So for suddenly applied load, sigma is equal to 2 into P divided by A. 2 into 20 into P, 20 into 10 to the power cube divided by A, 10 to the power cube millimeter square. Ten to the power cube Newton per millimeter square. If you cancel, it will come 40 Newton per millimeter square. Now we have got sigma V. V is equal to length into area is equal to length is given 2.5 into 10 to the power cube into area is given 10 to the power cube millimeter cube is equal to 2.5 into 10 to the power 6 millimeter cube. So U is equal to sigma square V divided by 2E is equal to (40 square into V 2.5 into 10 to the power 6 divided by 2 into E 200 into 10 to the power cube 200 into 10 to the power cube. Newton millimeter. After cancellation, we will get 10 into 10 to the power cube Newton millimeter is equal to 10 kilonewton millimeter. This is the answer. That's all for today. Thank you.